All right, now we're going to look at using a temperature sensor with an Arduino. This is an analog sensor. We used a push button or a switch as a digital sensor. And the main thing, and what we learned how to use with the switch and what we're going to learn with the temperature sensor can apply to other digital and analog sensors. We're going to look at temperature sensor, then the hardware assembly for it, and then coding for the temperature sensor. Temperature sensor measures ambient temperature. That's the temperature in the room. The sensor has three parts: a positive, negative, and a signal. So that's your hot, your ground, and the line that goes back into our Arduino. A change of, or a line that goes into analog A0 on the Arduino that we can actually measure. A change of 1 degree Celsius in the ambient temperature is a change of 10 millivolts. And that's what that sensor reports back to our Arduino. So there is a front, there is a back, there's a temp, TMP. Make sure it's a temperature and not a transistor. You might have to spread the legs out a little bit. Here's the diagram of this. Voltage for the sensor. This is voltage out. This is what's going to send a signal to the Arduino. And then there's a ground. And here we have it again. Here is the temperature sensor. Make sure it's not a transistor. We have the hot, the blue's the ground in this case, and the green goes back to A0. So the red is our 5 volts in the rail, and black goes to negative. Okay, let's begin by programming this. You have a constant integer temperature pin equal to 0. And what that's saying is assign analog 0, that pin, to the temperature pin. We name it temperature pin because that's easy to remember. And that's all right. Void setup, we're going to have pin mode, temperature pin. So that's the same thing as saying area A0 is an input, which we thought. And then we're going to use serial begin 9600. So that way we can see the value on our screen. All right. On the next slide, we'll code for the next loop. And so you're going to have on this load, float voltage equals 0, period, 0, semicolon. Float degree Celsius, 0.0, semicolon. Float degree Fahrenheit voltage, 0.0, semicolon. Float variables have decimals. Remember, we've been using integer, int. Well, this is a float. All right. Then we're going to say voltage equals a function we're going to make, get voltage, parentheses, temperature pin. Wow, we're going to get that. That's the A0 value. All right. It's going from that pin, A0, I should say. And then degree Celsius is the voltage value minus 0.5 times 101. All right. We're going to show you how to do the get voltage on the next slide. Degree Celsius calculation comes from the data sheet. Every bit of electronic parts have data sheets. And they're amazing and will provide you tons of information. And that was what gave us the information for this. So here's a data sheet for low voltage sensor. Here it is. It's telling you all, if you go through it, it'll give you all the information you want, the formulas, everything. Now, again, float voltage is right here, 0.0. Here's the get voltage is a custom that we've done. Here's degree C, voltage times 100. We just did that. And here's calculations for degrees Fahrenheit. And it's just the standard conversion you would see. So we up to this point, we're right to here on this. Then we're going to go and say serial print voltage, serial print the voltage value, serial print degree with a space, then degree Celsius, serial print degrees Celsius, print degrees Fahrenheit, df that value, and then serial print degrees Fahrenheit. So that's literally, anytime you see these quotations, it's literal. So this will say voltage, it'll say degrees Celsius, degrees F. Then after it is the actual value, and that's represented by voltage, that's represented by degrees C and degrees F. There's also delay. Label voltage followed by the actual voltage values. Again, notice why we only have print ln. Why do we do it and not anywhere up here? Give it a moment, think about it. Okay, think about it. You want these all going horizontally, but then when you get to the final value for degrees Fahrenheit, you want to go to the next line. Now we need to make a function. We're going to talk a little bit more about functions, and that when you have a function, in this case, it's going to be a float. It's not a void because we're actually going to return a value. So we're going to say float get voltage, parentheses, integer pin. So we have to pass it a pin, and it's going to be a whole number. That's why it's saying integer pin. So think about it. You're defining a variable inside that function. Remember, a float is a value with a decimal point. Inside the function, return, this says give us back a value. Analog read the pin, whatever pin you're going to do, read it, and multiply it by this value. This is an integer pin as a parameter. We passed it along our analog pin here. So you see this pin up here, whatever value we put inside of get voltage went down here where we did this read. So it says, so if we gave it A sub 0 or sensor pin, whatever, it was A sub 0. So say right here it's 0. This reads analog reads, well, pin is 0. It's like making a very specific variable for your function. That might help you think of it that way. This function takes an integer value and passes a float number, a number with a decimal point. All right? Again, getting this information off of data sheets. So here's how all the code looks. Go ahead and pause it now and see if you can fill this all out. All right? All right. Once you have worked this out, you should be getting a value. And you should be on your, make sure you run serial monitor, and you should see as the temperature changes, you should see the temperature go up and down. Put your finger on the temperature sensor, your body heat will warm it up, probably warmer in your room. All right. So that's this video on temperature sensors.